as for the ninth experiment of the data mining lab, I am going to perform the k-means clustering. That means from the finding the number of minimal clusters using k-means algorithm. So here I am going to use the replace set sample data, and I'm applying the k-means clustering algorithm. In here, for a sample, I'm just showing this k-means algorithm. This here I have given the cluster number as 2 and maximum runs as 10. Here I have given a breakpoint, so I will show what is there inside. The replace set is having these two attributes, attribute 1 and attribute 2, and the label attribute is already given for the performance. So after this, I'm going to run the I'm going to execute this. The k-means algorithm will add these two attributes, id and cluster. id attribute is having just for each row it will give an id as 1, 2, 3 and all. And for the cluster attribute, since we have given the cluster number as 2, it will give only two clusters, cluster 0 and cluster 1. According to the specific value, these two attributes are clustered in cluster 0 or cluster 1. So this is the model, and also this is the cluster model, and here cluster 0 has having 131 items and cluster 1 is having 119 items. So total now out of 250 items. So we are now going to perform k-means with performance and data to similarity. So we are taking the same replace set and we are applying the clustering model inside that. So this data to similarity is the new operator which we are going to introduce to you. So data to similarity is a similarity checking operator from the clustered operator. This data to similarity operator will be checking the distance measure from the exact data and the clustered data, and also this cluster is given as the output from this input port and other cluster, and from this data to similarity operator we are giving the performance operator. Here the performance operator we have used is cluster density performance operator. For this cluster density performance, the similarity measure is given as for the distance of a distance port, and the values are given in the AXA port, and also the cluster. From the k-means clustering, we are having two cluster ports. So from one cluster port number 1, we have given the output to the performance cluster port input, and from this we have given the output for this performance, and we have checked the performance cluster density performance for this algorithm, and we have checked the data to similarity. Now we will check the algorithm. So this is the initial data set we have given for the k-means algorithm. After this k-means algorithm, we have got two attributes, id and cluster. See, we have given the cluster value as 2, so we have got cluster 0 and cluster 1. So we have got the output as average within the cluster is minus 52.325, and average within the cluster distance for cluster 0 as minus 49.254, and average within cluster distance for cluster 1 as minus 55.705. So by this video I have shown you how to perform the k-means algorithm using RapidMiner and how to check the performance here from this k-means algorithm.